All right, well, let's get started. As people come in, I'm just going through the intro slides here, so no big deal. I see some familiar faces, but my name is Kamran Ayub. I've spoken at MidwestJS last year about TypeScript. If you're interested in like an introduction to TypeScript, you should check out my TypeScript Demystified from last time. This presentation is about patterns and practices, so it's everything that I've learned in a whole 6 months of using React, migrating one of my applications from Knockout.js. So, if you have questions about what I show, like I said at the beginning, it's too overwhelming to show you my entire application, at least the code. So I have bits and pieces, and if you have questions about what I'm doing, or if you have questions about the TypeScript syntax or what it's doing, just shout it out. I will explain it. So we'll do some ad hoc learning, because I don't know what you guys don't know. So if you don't know something, just shout it out. We'll cover it. All right. So like I said, I'm Kamran. That picture is me and a monkey. My wife and I took a 6-month sabbatical, and we were in Morocco. And the guide was like, "Hey, do you want to play with these monkeys?" And we're like, "Okay, sure." So he put like peanuts on our back, and they climbed up, and it was really weird. And then a Facebook friend was like, "Hope you don't get Ebola." So yeah. All right. I'm a packed author. I have a introduction to TypeScript course that I will peddle at the very end. I'm also really excited to be working on a Pluralsight course. So if you're interested, you can follow me and learn more about that. I've put my time in the uranium mines, so I have about 15 years of experience using JavaScript. And I will say that in the last 5 or 7 years is when I've been using it like day to day at my job. So I understand JavaScript. I love it. It's one of my favorite languages. Primarily I do a lot of .NET and C#. I'm also here based in Minneapolis. I work for a local big company. Soon I will be working for another local big company. And as far as this presentation goes, I have about 6 months of experience using React. So you might be like, well, what am I going to learn here? Because a lot of you are new to React. But that's cool, because I am too. So all this stuff that I'm going to talk about is stuff that I've learned in those 6 months. And coming from a background of making large applications and working on big enterprise apps, there might be some patterns and practices that could help you. So as a developer, you're probably asking, what do I want out of this presentation? And I ask the same thing. So this presentation is geared around answering a few things. First, I want to help you make applications easier to maintain. I'll go through what that means. I also want to help you make applications that scale, and I'll go through what that means. And also, I want to help you make apps faster, because I think these 3 things are things that I want as a developer. I want my app to be fast, I want it to be easy to work on, and I want to be able to add features, right? So what does each of these terms mean? Because they could mean different things to different people. So scalable is supporting 99 levels of navigation with jQuery, right? This is actual code that we had a contractor put out in one of our production websites. And I mean, you know, how else are you going to support 99 levels of navigation? Because recursion doesn't exist. So this is not what I'm talking about. Scalable, maintainable. When I say scalable, what do I mean? I want my code base to be easy to extend. I want it to be easy to collaborate on, because I'm not working on it by myself. Well, my side project I am. But on a team, I'm not working on it by myself. So I want other teammates to be able to easily comprehend what I'm working on. And I want it to be easy to reuse code. For maintainability, I want it to be easy to refactor. Code, once you write it, about 2 weeks later, you know that it's not that great, and you got to refactor it, right? It's happened to all of us. That's why there's software rewrites, because we determined that it's too much effort to just go and refactor the code, so we're just going to rewrite it. Nobody wants a read-only code base, right? And JavaScript lends itself to making read-only code bases if you're not careful. So we want to try to fix that. We want our code base to be easy to understand. A lot of teams are not static, they're really dynamic. You have people going in and out of teams, you have new people trying to understand your code base. Anything that helps people understand your code base better is good. We also want it to be easy to test. static typing and testing go hand in hand. They're not mutually exclusive. They complement each other. So this is where TypeScript and React come in. TypeScript, just a one-slide overview. It is JavaScript that scales. What does that mean? I just defined what scales means. So it scales in that way. It makes it easier to write and understand your code base. It's a static type checking language. So it's a superset of JavaScript, which means that all valid JavaScript is valid TypeScript. So all features in ECMAScript 2015, 2017, future versions of ECMAScript, all of that is implemented in TypeScript. Like, it's exactly the same. So they are trying to stay true to JavaScript. It doesn't have magic syntax that does code generation and stuff like that. A lot of it is very much the same. It has fantastic editor tooling. And I really say fantastic because one of the things that I value as a developer is productivity. And anything that helps make me more productive, I want to use. TypeScript has that, especially if you're using a really nice editor. The editor that I use is Visual Studio Code. It's cross-platform, works on Mac, Linux, and Windows. It's great for teams that want to use different platforms, open source projects, and it has absolutely awesome TypeScript integration. Visual Studio Code itself is built in TypeScript. It's a 100,000 some line application, and it's super fast. It's built in TypeScript. It's really cool. And TypeScript obviously helps you write more refactor-friendly code. TypeScript understands your code base, and it uses structural typing, which means that I can hit a button and it can go to definition for wherever I define that object or that variable. I can find references because it knows where in the code base I'm referencing it. It can follow imports. It can do all that kind of stuff. React is not a framework, I would say. It's a library. It focuses just on the presentation layer, so you can create reusable components. What I like about React is that it has a very small surface area. There's not a lot to it. You can learn it in a weekend. You could probably even learn it in a 1-hour talk. And I really like how it lets you create like reusable components. So you can define, just a small little item, and you can use crazy functional stuff like recompose, and you can build on top of those components. You can add to them. It makes it really, really awesome to create reusable components. It also has functional characteristics. Now, I wouldn't consider myself a functional programmer, but I do appreciate a lot of the functional programming paradigms. Stuff like immutability, purity, pure functions, that kind of thing I really like because it makes my code base a bit simpler. You could say also it adds a little bit of complexity because you're having more code that does less stuff. But at least those small pieces, those small functions are easy to understand. So it really just depends on how you organize it, which I will talk about. It also has great performance. So scalability, maintainability, that door, man. Scalability and maintainability is one thing. At the end of this presentation, I'll also talk a little bit about performance and how I got my application to go from like 800 milliseconds render time to about 4 milliseconds. And so I'll talk about that. The application that I will be talking about today is my own side project. It is non-commercial. You are free to use it. You don't have to. What I liked about using this as an example is that it's an actual app, and I wrote it in Knockout, and it's been working great for 4 years. And what I wanted to do is I wanted to make it more performant. So I investigated a bunch of libraries. I had no experience with Angular or Vue or React, so what I did was I took this part, just this rendering of all these games, and that was the least performant part of my app. So what I did was I just took a POC and I did a prototype where I did Angular, Vue, and React, and I implemented this part. No business logic, just rendering. And React came out pretty much on top. Vue was actually the best. But I think it depends on what you want. So Mark, in the keynote, he talked about, does corporate backing mean, like, does it matter to you? For me, like, the community and support and stuff of React was great. And also, the integration with TypeScript was really good, especially at the time. Vue 2.0 has really good TypeScript support. So you should check that out if you're interested. KeepTrackOfMyGames.com or KTOMG.com. It's built in .NET. It's a hybrid app. So this is different probably from a lot of talks you're going to see. This is not a single page application. This is a server-side application that has parts of it that are a single page application. So the list view that you just saw, that interaction, that piece, that's a single page app, but the rest of the pages are all server-side rendered. It was originally in JavaScript and Knockout.js, and I'm currently migrating it to TypeScript and React. So I'm not done yet, currently doing it. It has a very heavily interactive UI. So as an example, let me just go over and show you what I mean by like interactive. So this is the React version that I have up right now. So I'm able to do a whole bunch of stuff. You can select games and stuff like that, but this is just what I've migrated so far, the key part of it. In the production version, you can do a lot more stuff. You can create filters that read from your game list. You can add notes and stuff, where you can add notes for your games and all that kind of stuff. So this is a really interactive UI. You can change the sorting, all that kind of stuff. So there's a lot of interaction. So there's a lot of updates and rendering that's happening. So it was a good candidate to use React. Like I said, this presentation is based on a true story, right? It's a work in progress. I would say I'm about 20% of the way migrating my application. So all the patterns and practices you're going to see today are what I've learned so far. And if you guys rate this presentation and you like it, maybe I'll be back next year to share the rest of what I've learned. But I'm a lot like you guys. I'm still learning. And one of the best ways to learn is to do a presentation on it. So that's what I'm doing. Now let's level set on the tools and libraries that I'm using. I think this is helpful just because a lot of people for closed source projects don't really know what you're using. So for the build aspect, I'm using the latest Webpack. I'll show an example of my Webpack config. I'm using TypeScript, the latest version, 2.4. And I'm using TS Loader, which is one of the loaders that Webpack recommends. There's another one called TS Awesome Loader. That one's pretty cool, but I'm not using that one. For my React stack, now React applications is very much like a do-it-yourself Lego block type of development. So a lot of React apps use different bits and pieces to build themselves up. So in my case, I'm using React 15.4, not 16, the latest one, the Fiber beta. I'm not using that yet. I'm using Redux, of course, React Redux, of course, Redux Thunk, so instead of Redux Sagas. So this is to do like the async actions and stuff. And then I'm using Reselect for my selectors. I'll talk more about that. And React Bootstrap and React Transition Group. So I'm using Bootstrap. That theme is a customized Bootstrap theme. The other libraries that I depend on, there's a few more, but the main ones are Lodash, class names, which does conditional CSS class rendering, and then Moment.js and URI.js to do dates and URLs. Okay, so there's going to be some terms that I use, and I want to make sure that we're all familiar with what I'm talking about. So when I say store, I'm talking about the Redux Store. The Redux Store is your single source of truth for an application. Redux espouses the idea that you should have a single place. It should represent your entire application state. That was new to me. So I'll talk a little bit about how I organize that. But that's what it is. State, this is at a point in time what your application state is. It's just a big JSON object. That's all it is. It is everything that represents your application at this point in time. What's cool about Redux, and I haven't explored this yet, is the ability to capture that state and being able to do like time travel debugging or undo, redo, that kind of stuff. I haven't even gotten to that point yet, but I've been liking it so far. Actions, Redux actions that can be dispatched. So an action really is just a JSON object that has a type property that is a string that says, what do you want to do? Do you want to fetch your game list? Do you want to add notes to your game? Do you want to add a tag to your game? Do you want to delete a tag from your game? What I like about this is it's very much like the command pattern. It's pretty much the command pattern. You have a command and you have a handler. That handler is the reducer. So the reducer's job, this is such a weird term, I tell you. I don't know why they called it a reducer. I think in Vue it's called a mutator, which makes a little bit more sense. But it's a function that manipulates your state. So it takes an action, whatever you're trying to execute, and then it executes some code and it returns a new version of that state. Just the little slice of state that you're managing. That's what a reducer is. And then selectors. So I'll talk about memoization and selectors in more depth later on, but they are for computing derived data. So one of the things that I ran into early on was a lot of rerenders because I was doing a bunch of array manipulation, and it caused new properties to be sent down to my React components. So it made things really slow. So I'll talk about how I solved that problem. And finally, if you see stuff about services in the code examples, they're just plain classes that do business logic type stuff. So things, like HTTP services or validation and things like that that don't belong in components. They're business logic that should be pulled out of components. Great. There's a bunch of stuff I'm going to go through. So I have a little Candyland breadcrumb trail that you can follow. So the first thing that we're going to talk about is tool configuration. After that, I'll talk about how you organize your application, or at least an approach to organizing your application. We'll talk about how to configure your store, your initial state, how to represent that in TypeScript. I'll talk about how to handle reducers and make them type safe and compile time friendly. Then we'll talk about actions, how to define them, some tips and tricks that I learned to do that. I'll talk about props and state, both from a just pure React perspective and then Redux plus React perspective. And then action creators. So these are the things that it's just a function that returns an action. It's literally all it does. It returns a JSON object. So how do you get those to work? What do they look like in TypeScript? And then finally, we'll talk about selectors and memoization. First step. The first thing you're probably going to do working on an application is you're going to configure your build tools. This is my Webpack configuration. It's fairly straightforward, I would say. So we have different entry points. Remember I said this is a hybrid application, so I don't have a single entry point. Each of my major pages, like features, has its own bundle. So I'm using multiple entry points. Now what I noticed early on was when I looked at the bundle sizes for those files, they were pretty massive because Webpack is trying to be helpful, and for each bundle, it's just including the code that needs to be executed. Well, it turns out across like 4 or 5 bundles, and it's going to get even more. Like each of those things is like 200 kilobytes. And I don't want to have to be rendering that every single time because remember the browser has to parse your scripts when it loads them. That parse time is non-trivial. It's like 50 to 75 milliseconds to parse like 200 KB of scripts. So I'm using a plugin called the Common Chunks plugin. What's nice about this thing is that you just give it the node modules that you want it to package up, and it'll create a common bundle. So then you can just reference that bad boy on every single page. Then it only gets downloaded once, and then you can just have your individual bundles. These ones are only like 1 kilobyte, 2 kilobytes, 3 kilobytes because they were just my core code, my own code, not any vendor code. I'm not showing the TS loader config. It's the same as what Webpack default configuration is, so you can just reference that. The other thing that we have to do is we have to configure TypeScript. This is my TypeScript config.json. So if you haven't used TypeScript before, the TypeScript config is just the compiler configuration. There's nothing too interesting here except maybe this part. In TypeScript, when you want to use something that's outside of your target, so this is targeting ECMAScript 5, so it's compatible with a lot of older browsers. I want to use ES6 symbols. Well, then I have to manually make sure that I reference the libraries for those in the compiler, because otherwise you'll get compiler errors saying, I don't know what symbol is, because you're trying to target ES5. Symbols are not in ES5. So that's really the only interesting thing here. I'm using the common JS module system, so that's just the node module system. The resolution is node. There's a few other configurations you can do, but node is the one that you want. So that's all there is to it there. Let's talk about organizing our applications. So I feel like as a developer, for like the past 7 years of my professional career, I've been trained to organize my application into layers. So if I'm if I'm doing back-end development, I have my database layer, I have my service layer, I have my views layer, I got my models layer, and then you got files in those. And if you want to know which one references what, you've got to go all across the file system to try to figure out where things are being referenced. Well, it's how I started out with my app 2 on the front end. So we have our actions that hold the Redux actions that are available. Then we have our components folder that has like our left nav that is shared. We have the games components, all the stuff that are related to games. Then we have reducers. So we're just separating all of our stuff into layers. Well, I have an opinion about this. So first of all, files are spread out. I think that it makes sense to co-locate stuff that's related. So I don't like how the files are spread out, especially in JavaScript. It makes it really hard. And if you're not using TypeScript, you have to create, find my file type stuff, or you have to rely on your IDE to be able to find stuff. So at least with TypeScript, I can hit F12 and it brings me to the file. But you don't get that. You don't get that all the time. Import paths get super long. So if I'm down inside of addGameDialog.tsx, and I want to reference the store, well, I could go .. // go into store, go into index.ts, import whatever I need there. So import paths get long. This bothers me quite a bit. I think that this is okay for a small site, but this is just a snapshot. This is not even one feature. This is like one component. I can show you my real folder layout, but there's at least 15 or 10 components just in that feature. And there's even more reducers for the rest of my app, right? So it starts to get really big. What I have started doing, or would like to switch to, is a feature-based organization. So rather than organizing by layer, you actually organize by layer inside of a feature. So what's cool about this is that related stuff all gets put together. So if you have your games feature, you can have your actions, your reducers, your selectors, your services, all just right next to each other. Why not? They're all modules, so it makes it a lot easier to just import them right next to each other. Anything shared can just go above the features folder for common stuff. This also makes it easier to collaborate on. Remember I said that maintainability and scalability also includes your whole team. And a lot of us use Gitflow. If you've used Gitflow before, you're working on feature branches. Well, wouldn't it be cool if the features that you're working on aren't spread across the whole file system? And so when you're looking at PRs and diffs and that kind of stuff, it's all just usually inside the feature. And if you're making a change to a shared file, that's super apparent. When I'm outside the feature and I'm making a change, hey look, Kamran just made a change to the root store. Okay, well I better look at that because that affects multiple features, not just one feature. Like I said, co-locate related stuff. It just intuitively makes sense, but I feel like we've been trained not to do that. And closer imports. Now your imports for their component, you just go up a level to get that to get its actions and stuff. But there is a better way. Regardless of which way you choose to organize your folders, there is a sweet feature in Webpack and TypeScript called Aliases. Has anyone used Aliases before? Few people. Yes, you are smart. I learned this recently. This is great. So imagine you have something like this, like I was talking about. You're going up multiple levels to get to features, that kind of thing. This is okay, but nested paths are going to get even worse. And visually, as a perfectionist, it bothers me that my imports don't match nicely. So what you can do is you can do something like this, where you have your features is just like a capital features, and that actually maps to that physical folder, and Webpack and TypeScript both understand how to import from there. So what you can do is you can just have an alias for a specific path. To resolve that, or to add it to your config, I did not show this in my initial Webpack config because it's a big reveal, but you can add this section. Basically, the alias field is just a key value map where you have your alias, capital features, that then maps to the physical folder path in the file system that Webpack and TypeScript should use to resolve. It's pretty cool. If you're not using TS Awesome Loader, then you also have to make sure that the same config is inside of your TypeScript config. So it looks pretty much the same, but of course it's different. You got to have your /*, which I don't even know why you need that. And then instead of being just a straight up string, it has to be an array of strings. There's some more fancy stuff you can do with this, but if you just want it to be one-to-one, you have to do it. You have to do it like this, and make sure you have that star at the end there. So what's cool about that is that you can do this then, right? So then you can do import from features slash features slash features slash. It makes your imports a lot nicer to use. And what's cool about it too is you could change your file system later on, and you don't have to go and update your imports. So maintainability makes it easier to refactor, right? Okay, let's move into representing the Redux Store. Representing state shape. I think this is pretty interesting. If you're doing just vanilla JavaScript and you're not using Flow or TypeScript, if I asked you, what does your state look like? I mean, how would you answer that question? You'd probably have to go to your reducers and maybe see what the keys are that it's creating, that's mapping each of the reducers. But what's cool about TypeScript or Flow is that you can create an interface that represents your state shape. And you can pass this interface all around your code base, which means that your state is now strongly typed. So if you change one of these keys, it can change across your whole code base. You can hit F2, and VS Code F2 is rename, renames it across your entire code base. That's it. That's all you got to do. One of the things I want to call out here is this type of operator. If you're familiar with JavaScript, type of just returns the type of whatever object you're doing. But this is using the TypeScript type syntax. So in TypeScript land, type of means go and get me the literal type of that object or that interface and represent that here. So what's cool about this, we'll show in the next slide here, where you can export your initial state as a variable, and you don't have to necessarily use an interface. And when you reference it, TypeScript understands what that shape is like. So in this example, I'm creating another interface that extends one of my built-in ones, numeric store. I'll talk about that. I could choose not to do that, and rather than having to create an interface for every single type of reducer or every single type of state shape, I can just say, just use the type of whatever that variable is. So then I can change it in one place and it cascades down, which is kind of nice. So what is this numeric store state, and how am I organizing this a little bit? So one of the questions that I had when I was learning Redux was, how the heck do I represent my UI state? Because my UI state is going to have properties and stuff like that that don't really belong at the top level. So if I'm looking at my list, my organizing games list, I'm going to have stuff like, what's the sort by? Do I have permission to set privacy? Do I have permission to delete games? That kind of stuff. That belongs, I put it on a UI bag. So the UI bag just has a bunch of parts of my application. Right now, you can see I have like a global loading indicator. So whether or not I'm doing any AJAX or stuff like that, I can represent globally. And then the list organize is just what's the list organization UI state. The top level keys, the user is the current user, so it's like a user context. The games are the user's games because I reference them all over the place. So I have them at the global level. I could choose to store those games that are on that list inside the UI. I could do that. But since I use it all over the place, I just chose to put it at the top level. So here we see I'm importing the reducers from our features. So again, this is kind of nice. If I was organizing my folders the other way, it would just be like / uses reducer. So it'd be a little bit simpler. But now what's kind of cool is that I can still add new features, and I just come here and add that here. And they're all together. So I can work on a feature, I could add a brand new feature, and I just have to come here and reference it. But they're all kept separately together. So I just showed what this looks like. This is the structure that I've read about that works pretty well for me. You might be tempted when you're starting out using Redux to just put everything into arrays, but what you'll find out quickly is that you want to speed up the array lookup. And so what you should probably do is you should do a dictionary. So the by ID is storing a dictionary by ID of each game, so I can just do an order of one lookup to go and get my games. So it's a lot faster. And then if I want to have a count of all my games, I just do array.length on all IDs. Okay, so that's how you organize each of the levels of your state. But how do the reducers look in that example? So this is just what the state looks like, just so you have a point of reference, right? So you have my user, that's me. I have my all IDs. These are the games that I have in my list. These are some of my favorite games. and then I have my list and my UI. Okay, so that's kind of what it looks like in the end state. So if I was going to ask you, what does my state look like, you'd have to go look at this in order to tell me. But with TypeScript or Flow, I can actually define that up front. So this is what the reducers look like. This is the root reducer. This pattern is really nice. So you're importing your each of the default reducers from these files, and you're just combining them into a list. You're using the combined reducers that's built into Redux. And so I'm just passing it in. Really the thing to call out here is here's where I'm importing my app state. So with TypeScript, I can strongly type what this is, this root reducer. I can tell it, this should match app state, which means that if I am missing a property on here, I'll get a compiler error. Or if I rename something, I'll get a compiler error. If I add a new reducer and I add it to my app state, which is what I should be doing, so I'm adding a new part of my state, this file is going to throw a compiler error. So I know that I got to go and update my root reducer because it just added some new state. So that's really nice. Inside of that individual reducer, this is just an example of a games reducer. I have my interface, so this stuff you saw before. This is the same code, nothing different here. But what I've added here is a few functions. So what's kind of neat, at the very bottom, oh, it didn't update. Go over here. All right, so down here, I'm doing the combined reducers again. So I'm taking this JSON object that has the all IDs, by ID, by list ID, and I'm creating individual functions that are those reducers. So now I'm creating a big reducer that does 3 things, right? For a single action, it would have to update 3 keys. I'm not doing that, I'm separating it. So it's a little bit more like single responsibility type thing. And what's cool is I can set the initial state to my constant up there. So the initial state is always going to be this empty array for all IDs. It's always going to be this empty object. I could add other default state if I wanted to here, and I can reference that. So what do we do about these actions? Well, first we have to define them. So let's move into actions. What's cool about TypeScript and Flow is you can do constants. And constants you can do in ES6. But how does that work in the type system? Well, what's really cool is that if you're using a constant, TypeScript actually infers that type as the literal type. What the heck does that mean? So I have my constant SaveGameNote. This is the action I want to perform. I want to save a game note. Right now I'm setting it to a string. So could anyone tell me if I hover over this in my editor, what would TypeScript infer that type as? Would it be a string? So the answer is no, it would be this literal string. It would be SaveGameNote. So this is what I'm talking about. Let's go to the live example. All right, so let me just zoom in here so you can see. If I hover over SaveGameNote, the type, so you see this type, the colon indicates the type suffix. It is SaveGameNote. It's literally SaveGameNote, which means, let me get it back here. So this code here, where I'm doing export type of SaveGameNote. Remember I'm using type of earlier when I was doing the store. This is saying that this type property must be SaveGameNote. Can't be anything else. Can't be another type of string. Can't be any other string. It has to be SaveGameNote. And the cool part is I can do F2, rename this action across my code base. It's all updated. All the references are updated. I don't have to go and search for where else am I using SaveGameNote. I could call this constant something different. I could call it, SaveGameNote action and then not in all caps. And then this will update to type of SaveGameNote all action. Okay, cool. This is just the same thing. So this type, this export type, just think of it like an interface, but you don't implement types. It's just a description of a type. This type is describing the shape of a JSON object, indicated by the curly brace, of course. I have my type, my game ID, my body. That's the JSON object shape that I expect for this action. So you might say, well, that's a bit wordy, but trust me, it pays off at scale. You have hundreds of actions. I already have like 40 actions. I don't want to have to go and update them across my code base anytime they change. So doing this kind of thing is really nice and scales really well. So you can group similar actions. Here I've introduced a new action called delete game note. it's the same thing, nothing too crazy here. I'm referencing the constant type. And then I have this thing here at the bottom. So this is in my gameActions.ts. So in my reducer, I'm going to be handling multiple actions. Do I want to, in TypeScript, reference every single one of these actions in my code? Because if I did, then that's going to be a maintenance nightmare, because my actions are going to change. I'm going to add new actions. There's going to be new stuff that I want to do with games. I don't have to go into my reducers and add that type annotation every single place. So what I do is I'm using something called a type union. So a type union just defines a new type, the all type, that says I'm a union between save game node action and delete game node action. So that's really cool. So basically it says I could be either this or this. And then you have 100 more you can list here. And then all you have to do is reference this one type, and then you get access to all the rest of the types. What does that mean? So back in my reducer, I import that. I import everything as actions so I can get access to the constants that I'm exporting. And I get access to the actual the type aliases. So here we see that I am referencing actions.all. So in my games reducer, I want to handle all game actions. I don't care which one it is. But what I could do is, based on that type, here I'm referencing the constant, okay, and I'm calling another function, handle save game node. So I'm splitting up my functions. And here, check this out. So I'm referencing that action, save game node action, and I'm also doing it down here in this other action, and this is all working. Sorry, I got my cursor messed up. So this is all working because TypeScript understands that these different actions are different based on the type. So this is called discriminated unions, and it's an advanced feature of TypeScript, but it's just the coolest thing ever. So yeah, I got some boilerplate code that I showed earlier, but down here, so we have action. This is saying that this action could be either save game node type or it could be the delete game node. And it understands, once I'm in here, underneath the switch statement, that that's a save game node action. So you know what happens? Down here, if I change this code to go to delete game action, this is so cool. And then I go scroll back up, big reveal, I get a compiler error because it says, hey, you're expecting save game node action, or you're expecting delete game node action. I know that this is a save game node action. You can't do that. So it's really cool. So makes it a lot more maintainable, makes it easier to understand. All this IntelliSense stuff is all inside of Visual Studio Code. I think Sublime Text might also support IntelliSense like this. Like, to me, this is like invaluable. Like, this is what I want as a developer. I don't want to have to worry about the types of stuff. Just wanted to understand and tell me what it is. Cool. All right, props and state. Getting into components. There's nothing too interesting here except how I'm organizing my interfaces. So in TypeScript, interfaces, they're just contracts of how you want your objects to be like. So this is just saying the props for this component has a game ID, it has a note, it has a handler that's like on save or whatever, on edit. And then for state, I'm also describing the state of my component. So, I mean, I think that this is valuable. Being able to see at a glance what's going to be on my props. Because if I asked you, what is on your props? What would you have to do? You have to go into your render method. You have to go into all the methods inside of your function or your class, and you have to itemize which one of these keys is it referencing. Don't have to do that with TypeScript or Flow, of course. You can define all that up front. So now you're saying, these are the props, these are the state, this is what it's going to be. If you're not on here, you're not going to compile. And what's cool about this is it flows throughout the JSX. So in your JSX, you're like, I want to use my edit game node component, and I'm passing, foo. Foo doesn't exist on my props, it's going to be a compiler error. So you try to do foo equals bar or whatever, it's going to throw a compiler error. So make sure that your JSX is strongly typed too, which is awesome. Down here, this is how you reference it. So the pure component is a declaration that lives. Someone created the pure component declaration file. This is just the class that you can extend. This is using ES6 classes. So again, this is the stateful example where I have a state in my component. And I'm strongly typing it using generics. So if you're from Java or C#, you're familiar with generics. If you're not, just think of it as like type substitution. So this .props is going to be a type of props. This .state is going to be type of state. Okay, it's just like substituting what those types are going to be. Awesome. For stateless, it's pretty much the same. I'm defining my props up front. The only really big difference is that I'm just typing it as React.Stateless component. So this means that this function should follow this definition where props is of this type. So when I'm inside of my JSX here and I do props dot whatever, I'm going to get IntelliSense because it understands that the type of props is going to be that interface. No big deal. Gets more interesting, I think, when you try to work with Redux, because Redux adds some stuff onto your props. And how do you represent that in TypeScript? So here at the top, the only difference that you'll probably see from regular Redux and regular JavaScript is I'm importing another thing called dispatch prop. That is a type. So that's a type from the declaration file. That dispatch prop is the dispatch function that goes against your state. So you have like this .props.dispatch that Redux adds. That's the definition of that. Then I'm importing my app state. Like I said, I can import my app state shape anywhere so I can strongly type everything. And this is the same. I got my props, but now I have a new interface called state props. Well, what's that? So remember when you connect a component in Redux, you have your map state to props function. That allows you to add new props that get passed into the component. So how do you in your JSX, how do you reference the regular props? But then when you are inside of your component, how do you get access to the new Redux props that get passed in? So this is a representation of state props. Then what you do is you do a little trick down here, and you use this little symbol. This is a type intersection. This is saying add the properties from props and state props together. As long as they don't conflict, they will end up in one type. So you're representing multiple disparate types together using an intersection. And then I have my dispatch prop, and I'm strongly typing the state of that dispatch right here. So then in my dispatch function, it knows that the state is the type of app state. So I'm strongly typing that all the way through. Then in my map state to props, I'm doing the same thing. State is the first parameter. That's standard. But now I'm typing it to app state. So I have my strongly typed version of my state. And then own props. This is the component's own properties. That's the props interface. This is the default props of my component. And then this map state to props returns my new state props. So just the state props. Can delete. Right? So now I have game ID, which I'm passing in through my JSX. Then I have can delete, which is mapped from my Redux state. And if I did this .state or this .props, I would get access to both of those properties. So that's what's a type intersection. That's pretty sweet. Also worthy of noting, down here, it's exactly the same as just vanilla JavaScript because I've typed everything appropriately up here. So, interesting thing I think to call out about TypeScript, that you don't have to type everything. As long as you can get it to infer your types, then you don't have to type everything. Because this is actually a generic function. I would have to pass in all my generic arguments here, but I don't have to because I've already typed it properly up there. Cool. Next. Stateless is pretty much the same thing. Again, I'm referencing my stateless component. I'm doing my intersection, and I have my dispatch props. So these is all the same code. It's just that I'm referencing the stateless component. Okay, that's cool, but I just want to call out a couple things here. This kind of offends me, like as a developer. I don't have to keep doing this all the time. So there's a couple patterns that we can look at here. First of all, I know that I'm always going to have dispatch prop when I'm dealing with Redux. It's always going to be available. It's always going to be mapped. I also know that it's always going to be app state because I'm working in my app. It's not going to be a different state. I don't have two stores. I have one store. It has one shape. It's always going to be app state. So what we can do is we can just create an alias, essentially. We're just going to create a new class. We're just going to call it Redux Component. And we're going to use default generic types, which is the coolest thing ever because we don't have that in C#. So what this lets you do is you can leave off generics and you can just use default types. So then you get to use as much generics as you want to that matter. So if you want to just say, my class foo component extends Redux component, and you don't have props and you don't have state, that's all you need. You don't have to put in the generic arguments, because by default, it will just type them as empty object. Then you just extend the pure component that comes from Redux, or from React. And you can pass in our hard-coded dispatch prop, and we're importing it, and our app state. So now that's all typed, and we do the same thing for stateless component. And now that's simplified. So this is what my stuff looks like now. So I have my Redux component, and I'm just importing from my common features from Redux. And I can pass as many of these as I want to. I could say just props, and then there's no state, so it's a stateless. And then there'd be no state props. Or if I'm not mapping any new properties, I should say. If I'm not mapping any new properties from Redux, I could leave that off. And then for state, if I don't need state, I can just leave it off. I don't have to define those generic arguments. Same with stateless. So I think that this makes it a lot easier to read and also avoids all that duplicated like construct boilerplate for dispatch prop. We're doing pretty good on time. I think we'll be able to get everything done. So action creators. Action creators, like I said at the beginning, are just functions that return the action description, the plain old JSON object. So this is all the same code you saw before. I've added a new function here. I take my game ID, the body of my note that I want to add to my game, and here's the TypeScriptism. I'm typing it as the SaveGameNote action. So what it's saying is that this function should return a JSON object with the shape. So this is kind of cool, because you know what this means, because I'm using literal types and constants. If I try to change this type, it's going to blow up. So if I try to change this to delete game note, it's going to say, hey, you said it's a save game note, not a delete one, so I'm going to throw a compiler error. So it just makes sure that you're consistent with the way that you're doing your actions and your creators. You could do it this way. If you don't want to type it right here, where you're saying the return type of my function is this type, you could say force this JSON object to be, it's just doing the type casting. You're casting this type. You're just saying this JSON object is this type. Trust me, it is this type. It'll accomplish the same thing. Dispatching these actions. So one thing that I learned was I didn't want to use bind action creators. That's one recommendation that you can do, but I actually found it a little bit hard to strongly type because it's very dynamic. And it's possible that you can do it. It's just a little bit more maintenance overhead that I didn't want to deal with. So instead, that's why I'm using that dispatch prop. So I'm just doing this.props.dispatch, and then I'm importing my actions from my game actions. That's the action creator. And I'm just passing in the parameters that I need. I'm missing one. It's supposed to be passed. I'm supposed to be passing in the game ID, but really, there's nothing too interesting here except that this is all strongly typed. So I can, if I pass in, so this would not compile according to this, right? Because I'm expecting game ID, I'm not passing it. Because I did this in my slides and not actual code, there's no compiler error here, obviously. But if I did this in my actual code base, it would throw an error here. So I wouldn't have to wait till runtime to realize that I misused an action creator. So that's pretty cool. Async actions, a little bit more interesting. So one of the patterns that I saw that I wouldn't say that I like, but that I didn't mind too much, was to add like an underscore success or underscore failure action type. So let's say save game note in reality is an async action. I'm going against my web API, updating the game, returning the new game results or whatever. I need an action for updating my state. So on the client side, I need to update my state. That's still this save game note action, but then I need a way to initiate the AJAX request. So sorry, I got that mixed up. Save game note is the initiation of my AJAX request. Success is that AJAX request came back successfully, so I can update my state. I could also add an underscore failure. I'd probably recommend doing that, because if there's a failure, which there inevitably will be, that allows you to take action. Maybe you want to undo something. This is all the same, except that I've renamed save game note to save game note success. So it's all the same thing that you saw before. I just renamed it. I'm referencing the new type here, and because I've updated it here, it's make sure it's all strongly typed. But then I'm adding some new code down here. So this is a bit of a wordy thing here, but we have our SaveGameNoteAsync. I'm just defining up front that yes, this is an async method that will return a promise. And what it returns is this dispatch function here. This is part of Redux Thunk, the middleware. This is how it expects your actions to be for Redux Thunk. So all it is, it's returning a new function. That function takes a dispatch and a get store. And you can strongly type both of those, which is cool. And then this is where my code is. So there's that game note service. That's just the HTTP service. I'm doing my put, and then I'm passing in my parameters. And if that's successful, I then dispatch the action that goes and updates the client-side state. If this result was a failure, I could then go and dispatch a failure message that could do something else. Steven, you look like you have a question.
No, it's okay. I was just wondering where you actually called it.
Where I was actually like dispatching the action? Yeah, so this dispatch that gets passed in is the same dispatch that I was using in my component. So it goes through the same, like I go through my reducers and it executes the reducer stuff. And then I'm returning that value back through the promise. So the way that I can consume this is like this. This might help. So I'm using my props.dispatch, and because this is an async function that returns a promise, that all gets typed through. So then I can do .then because it's returning a promise. This result.value is the note from the game. So there's note. I'm doing something here. I thought that I had oh yeah, I do. Next slide. This is what it looks like in the editor. So everything is strongly typed here. So I have my save game note. It knows that game ID is a number. It knows it's a string. It knows it's a promise that then returns a game note. It's all strongly typed. So you don't see any TypeScript types here because I don't need them because it already inferred it through everything else that I've done. So it keeps the code a little bit simpler. This looks like vanilla JavaScript, but it's TypeScript. And then, of course, it's just going through it, showing that everything is still strongly typed. So I get compiler errors if that ever changes. So if I ever return something other than note, I will know because this will fail. Selectors. This is the final piece of this Candyland puzzle here. So selectors are a way to compute derived data. Let's just take a really quick example. We have our function that does something complex. Searches a collection. It takes, O(n) squared time to do it. Well, if you execute that function 100 times, then it's going to slow down your app. But what if we instead already know that we calculated that value for that ID and we just return it? It's basically caching for functions. That's all, like memoization, that's all it is. Lodash has a really nice function called memoize. You pass it your function reference. It gives you a new one that is memoized. So you literally don't have to do anything. You don't have to implement this code here unless you have more performant ways of doing it yourself. So why do we do that? Because you will learn early on that in map state to props, if you're doing any kind of manipulation of your state and passing that down as props, and those changes, it's going to cause re-rendering. And that's because by default, map state to props does shallow equal comparison. So if you go to Redux talks, they'll say Redux replaces should component update. Well, that's why, because it's doing the shallow equals comparison for you. If you want to, you could change it to a deep equals, but I mean, why bother doing that? Because that's just going to add an unnecessary overhead. Instead, you can solve it using something like Reselect, which is a library that React has that basically lets you do the same thing. You have your basic selectors. So this is just going and getting properties from my state. There's nothing special about this. This is just a function, takes in my state, returns a property. Nothing special there. This is where it actually creates the selector. The arguments that you can pass it are the dependent selectors that you want to use. So the last value is another callback. Each parameter is the result of these selectors. So why is that useful? Because Reselect can then make sure that once these values are computed, it does not run your selector again. So with the same parameters, you will get the same result, the same instance, which makes the shallow equals make sure that that's always the same. So what caught me and why I had to do this was because I was doing a lot of Lodash manipulation. Well, it turns out Lodash creates new arrays, right? When it manipulates stuff, it was causing a lot of re-renders on my application. So a practical case of when this is useful. At the top of my game list, I have my four albums, like the box covers or whatever. I need to compute that. That's computed data. I take the first 4 games and I get their thumbnail URL and I put them in a CSS background. So there I'm using Reselect. So I have my get game selector that I have here, get games, that's already a selector. I'm creating a new one called get top images, and I'm just saying I depend on get games. That returns an array of games. Then I use my Lodash to take the top 4 and get the thumbnail URLs, and I do that in my map state to props. That way, as long as the games don't change, they'll always be the same instance of that array. Therefore, it will not re-render that component, which is nice. Finally, those are all the patterns and practices that I have. But let's talk about performance and what motivated me to move to React and might motivate you. So this is also a quick story about how I went from 800 milliseconds of re-render time down to 4 milliseconds, because we have to go fast. I want my application to go fast. That was the whole reason I wanted to go to React. And imagine my surprise when I did my measurements and I saw that it was taking 800 milliseconds to render my game list. It's like, you gotta be kidding me. I did all this work and it's slower and I don't like it. So what's going on? So first let's talk about what am I measuring. So I was measuring the initial render time. That's the time to render that list of games. The re-render time for a single item. So when I do my select, or I'm selecting a game, it has to re-render that item. And then the time to dispatch an action, which was non-trivial. So I encourage everyone to measure in development mode, by the way, because first of all, you get better timings as far as debugging goes. And then if you solve problems in development mode, they will be solved in production. So how am I measuring? Console.time, time end, using the lifecycle hooks of React. I was doing that. Also, really cool tip, if you do !React_perf in your browser, you'll get timings down in the Chrome timeline. Cool. I learned that recently. That was pretty sweet. So then you can see that I'm seeing 400 milliseconds of my game list update. So you can use that to also try to figure out what your components are doing. So the before times. Initial render time was 800 milliseconds. That's the time to render 300 games to the screen. The re-render time when I clicked a game, it was still 800 milliseconds. The time to dispatch an action. So that was the click. The click blocked the UI for 1500 milliseconds. What's going on? React is supposed to be fast. So the first thing that I did was I followed my own advice. I memoized all my selectors and map state to props. That brought down that re-render time from 800 milliseconds to 30 milliseconds. That was much better because what it was doing, the times lined up, right? So as you can imagine, it was re-rendering every game. And I just did console.log in the render method to determine that. But also correlating the times, likely that it's re-rendering your entire list. So fixing that, I fixed the shallow equals. That solved that problem. The second thing that I did, there was some advice that I read. Instead of passing complex objects down to your children, just pass the IDs, because in map state to props you can go look up that child. So that actually brought down the re-render time even more. So from 30 milliseconds it brought it down to 20, because not every single the parent component isn't doing all that mapping before it passes it down to the children. It's the delegating the child to go and look up the objects in the state. The next thing I did, I was following some advice online when I was learning Redux to use this middleware. So what this does is it actually does a check that says every time you dispatch an action, did you mutate the state? And if so, I'm going to warn you about it. So it's great in debug mode. I did not realize that it adds that much overhead. So I removed that bad boy and I got back my 40 millisecond dispatch time, which, it's still long. It's still a long time. Next optimization, simplify my render logic. So what I mean by that is, what I noticed is that the biggest impact to my performance was how many elements I was rendering. So shorten that, you shorten everything else. Last optimization that I did, virtualized the list. So rather than rendering 300 games at once, render 30 to 40, and as you scroll down, add more to that list. There's a good component called React Virtualized List that kind of does that. I did it myself, but that brought it down from 800 milliseconds to 200 milliseconds. So afterwards, these are the times: 190 milliseconds, 5 milliseconds, 10 milliseconds. Way better. These aren't lies. This is what the actual console reported out. In production, 72, 5, way better. That's what I'm looking for. That's the performance that I want from React, because I want it to be fast as hell, right? It's fast as the Flash. And I'm not done yet. It's all about UX. This is probably too long to show. What you'll see if you watch this video is that the Knockout.js version, every time it was appending to the list, was about 800 milliseconds. So it's like ridiculous. It has a huge impact on UX. There's always room for improvement. I'd like to get down to 50 milliseconds. But what I want to end with is, like, this is my son. He's 6 months. He's super cute. He's learning to walk, right? And I think that we're all learning stuff in JavaScript and React and Angular. These are all new frameworks. They haven't been around that long. I feel like we're all taking baby steps. And I'm just really happy to be here to share my learnings with you. Appreciate your patience and listening. And you can follow me on Twitter. You can take my Introduction to TypeScript course. It's 8 hours long. It's very comprehensive. You can follow me on Twitter if you're interested in following me. But otherwise, definitely check out the rest of these talks for the rest of the time here if you're interested in learning more about React and TypeScript. Thank you very much.